Hello everyone and welcome to part 2 of our Unity game reversing series. Today we're going to be creating GUI elements using the OnGUI function. And then we're going to use that knowledge that we learned about creating UI elements to create an ESP. So let's get into it. So we're going to be using the same project that we used in the past tutorial. If you haven't done that past tutorial, please go back to it and do it. You need that knowledge, otherwise you're not going to be able to do this. I've actually redone this for a different game, so I added references to a game called Muck. That's what we're going to be using. So I just removed the references for Paint Warfare, the game that I did last time, and added Muck's DLLs. So everything's the same. I have emptied out the Hacks class here to only have the basic structure. And if you don't know what I'm talking about, it's probably because you haven't watched the tutorial, so go back and watch it. And if you just want a refresher, that's fine too. But anyway, so let's get into it. So first, I'm just going to be covering UI elements. How do we create UI elements? So basically, what we're going to do is we are going to create our OnGUI function. So inside of this OnGUI function, I talked about it briefly in the past tutorial, but basically it just is where all the GUI elements are rendered. What we're going to do quick is just to show you the basic GUI stuff. We can just go to GUI dot, and then we can see all the different elements we can do. So we can do a label, we can do a button, we can do a box, that sort of thing. Let's try doing a label. So we can do GUI.label, and then we can create a new rect, and then we gotta put in the position of that. I'm just gonna do it at the top left of the screen. So 0, 0, and then the width, we could do, I don't know, 100F. Height, we can do like 30. And then the text, we can just say, this is a label. Alright. And now we can go into Muck, inject it, and you'll see it rendered. Alright, so now that we're in Muck, I'm just going to go to my files, go to our Sharp Mono Injector, open it up, and then I'm going to Control-Shift-B and build our project. So now I have the Muck tutorial DLL. I'm going to go here, refresh the process. Alright, assembly to inject. I'm going to paste in that path there. Press enter. And Muck tutorial, the namespace works. Our class name, if we go here, class name loader. Our method name is init, so just put that in there. Then we can go here, hit inject, and you can see we have the label. There's the version number here, so you can't see it that well, but you can obviously see that it rendered. So let's say do a label. I'll show you quick just how we can do a box. We'll do a box and then the label on top of that just so you can see it better. And then we'll move on to the ESP. I'm going to go ahead and do GUI.box, and we want this to render before the label, that way the label is on top of it. So we're going to do GUI.box and then do new rect, and we'll do again the same stuff, so 0, 0, and then we want it to be like, we'll do 100Y, just keep it the same as the label, and then we're going to go ahead and do 30. Alright, and then the GUI content, we can just leave this blank. So inside of a box you can put text, but since we already have text as a label, I'm not going to do that. Anyway, so build this again, and I'll go into Muck. Alright, so now that we're in Muck, we can just go here, copy our path here. Actually, it should already be in here. Yeah, so if we go to our injector, refresh the process, assembly to inject, double click on Muck tutorial, press inject, you can see we have our box and our label. So that's just basic GUI stuff. Now we're going to move on to rendering boxes, outline boxes, lines, that sort of things. So like the really basic rendering stuff that you would use in an ESP. So I actually have a render class that we're going to add here. So I'll put the GitHub, the gist, in the description. But we're just going to take this code, yoink it, and I'm going to create a new class, add new item, class, call it render. Alright, and then we can just paste it in there. Let me check if I copied the whole thing. Nope, so I just copy the class. You want to make sure you only copy the class, not the namespace, because your namespace is probably going to be different. And then we're just going to do using Unity Engine. Alright, once we have that, we can see that we get no errors, and we're good to go. So we're going to be using things like drawbox, draw line. We're going to go ahead and do draw line, so I'll show you what that looks like. So we'll go here, GUI, sorry, not GUI, we want to do render dot draw line. Alright, and then we can go and do, I don't know, let's do new vector2 0 0. Alright, and then we'll do new vector2 100 100. Alright, and then we're going to do the color. We'll just do color.red. And then the width, we can just do 2. So now we're going to do drawbox. So we're going to do render.drawbox, and then we're going to do, I know we have this suggestion here, but there's actually, this is the function we're going to be using for our outline, and it's basically just drawing 4 lines. So we're going to do float x, so we'll do 500, 500, and then for the width we can do 200, and then for the height we'll do 200 as well. Color we'll do color.red, and then the thickness we can do 2 again. So let's build that. Close out of muck. Alright, refresh. Find our DLL, hit inject, and as you can see we have our box and our line. So these are the 2 things that we're going to use for our ESP. So now you have the knowledge of basic rendering, creating GUI elements, and now we can move on to actually making the ESP. I'm just going to go ahead and delete this stuff here. We can just keep a label here and, I don't know, make it say ESP or something. But now what we're going to do is we need to find what GameObject we want to get the position of. So instead of, since it's internal, instead of finding a pointer that's the player's position, we would just get the player's position by accessing that GameObject, and then the GameObject's transform component, and then the position of that GameObject of the transform. So we just be doing, GameObjects.transform.position, and that's how we get it. So first we need to know what GameObject we're getting. So we're going to open up dnspy. Alright, and once we have dnspy open here, we can just go to our muck files, go to muck data, managed, and then assembly C#, and essentially assembly C# first pass. So we just gotta look in here for a player class. So it's not gonna be in first pass for this game, might be in for the one that you're doing, because this does work for any Unity game. So now we're gonna go into here, we'll look for player, something like that, network player, something like that, just has anything. Okay, local player. See, this looks like something that could be it, but I know from reversing this game, I've actually tried using this GameObject, it's not it, it's not what you want. And also, you don't want to draw ESP on your local player anyway. So we're going to keep scrolling, look for player, online player, here we go. So this is the GameObject we want. So we in the class online player, we have the GameObject online player. So we're gonna go in here, and we're gonna loop through each online player in the scene. So the way we do that is we're gonna do a for each loop, and then we're gonna do for each online player, and then we'll just call it player in, and then we're gonna do Unity engine dot object dot find objects of type. Make sure you do objects, not object of type. And then we're going to do type of, and then just the same type that we did here. So online player as online player array. And basically what this is saying is we're going to look for the game, the object of type online player in the entire Unity scene. So once we got this, we can get into getting our player's position. Not our players, but the enemy's position. So we'll do in-game position, and this will be a vector 3. So we'll do vector 3 pivot position, and this is the player dot transform dot position, and this is pretty simple. It's easy to understand. And vector 3, all a vector 3 is the x, y, and the z, and we're going to use a world screen function later to turn that x, y, and z into screen position, which is just x and y. Anyway, so next up, now that we have this pivot position, but there's an issue with our pivot position. So while I have this pivot position, it's set to the player position. It's not actually at the feet of the player. So we want our ESP box to be at the feet, starting at the feet of the player, and then we're going to make it stop at the head, right? So basically, the issue with this is this pivot position is actually halfway into that. So since that pivot is actually in the center, and not at the feet, we need to offset this pivot position by subtracting from it to get the feet position. So we're going to do a vector 3 player foot position, and this is going to be literally just this pivot position, except down a little on the y-axis. So that's the up and down axis for Unity. So we're going to do player foot position equals, or dot x equals pivot position dot x, then player foot position dot z equals pivot position dot z. And this is where we offset it here, is we're going to do player foot position dot y equals pivot position dot y minus 2f. Now you're gonna have to experiment with your game, because the height and width of the player is different for each game. So this might be 1f for you, this might be 3f. And when I'm saying f, it's just because this is a float. So it's just 1, 2, 3, but it's float. So anyway, so once we have this, we can go from here and find our head position. And the head position is, again, just calculated by adding to the pivot position. So we're going to do vector 3 player head position. Actually, I said that it goes off of the pivot position. You could do that, but instead of doing that, I'm going to go off of the player foot position, just because that's what you would do in a normal game, is that the foot position would be equal to the origin, so like the feet. But anyway, so then this is going to be player head position dot x equals player foot position dot x player head position dot y equals player foot position dot y. Sorry, dot z. Dot z. The y is where we're gonna, change it up. So, okay, so I actually made an issue on this line. As I'm editing this, I just realized I fixed it later in the video, but just so you guys know in advance, this line should be this. Now I'm just going to show you what this means in game. Alright, so here we are in game. I have my friend here, and he's just going to stand still. As you can see, I have 3 lines here in an ESP box. Now, you're not going to have these 3 lines in your final ESP, but this is somewhat what the ESP will look like. So you have your ESP box, and you're going to have one snap line. So like the snap line in the middle, or you could have it connect to the bottom, whatever. So basically, this red line right here, that is the GameObject transform position. So that's the position of the GameObject, and that's obviously not where we want it. We don't want it in the middle, we want it at the feet. So that's what we did earlier, where we have our offset. So this offset -2, that's just subtracting 2 units on the y-axis. That way it's down at the feet. And then since we subtracted 2 there, we just add 2 again, so that's 2, and then add 2 to that, and then we get the head position, so that's 4 in total. So height of this guy is roughly 4 units. Alright, so now we're back in Visual Studio. I hope that, helped to explain a little bit. But basically, now we have to turn these world coordinates into screen coordinates. So X, Y, if you have a 1920 by 1080 monitor, that sort of thing. So I'm going to go here and put screen position. And the way we convert this is by using a world to screen function. Now, in a normal ESP, like an external ESP, you'd have to make your own world to screen function. But since this is internal, Unity already has their world to screen function, and all we have to do is access the camera and then call a simple function. So we're going to do vector3 world to screen underscore, we do player foot position, or we'll just do foot pause. Alright, and this is going to be equal to camera, so we're accessing the camera, the main camera, and then world to screen point, and then we have to put in the vector3, so what point we actually want to convert, and we're going to do the player foot position, so player foot position. Alright, and now we're going to do the same thing for the head, so I'm just going to duplicate that, do world to screen underscore head position. Alright, and then we're going to just start drawing our ESP. So I'm just going to say, real quick, put some comments just to add some more clarification. So here, this is the pivot point, not at the feet, at the center. And then this will be at the feet, at the head. So now we're going to get into rendering our ESP. So we're going to go ahead, I'm just going to delete this start function because we're not going to use it, for now at least. And then we're going to do a public void draw box ESP. And there's a few variables we need to input. So we need to have our 2 vector3s here, our 2 world to screen vector3s. So we're going to do our foot position and our head position. And I like to just put the color in there just in case we want to have, we want to be able to change our color simply and easily from here. Alright, and this is the Unity Engine ESP, or rendering ESP. Alright, there we go. And I said color.color. I don't know why I said that. I meant to do color. There we go. Now that we have that, we can do float height, and this is going to be the distance from our feet to our head. So that's calculated by doing head position dot y minus foot position dot y. And then we're going to find our width. So we're going to use a width offset because there's really not an easy way that we can calculate our width. So we're just going to do a float here. So I like to just do 2. Or you gotta adjust this for your game, but I'm going to do 2 for this. So then for actual width, this is just going to be equal to height divided by that width offset. Alright, and now we're going to go into rendering our ESP box. So I'm just going to say ESP box, and then we're going to do render.drawBox. And remember, it is this one here. You don't actually have to do the arrows, but I'm just doing it so you guys know what variables we need to put in. So our x is going to be foot position dot x minus width divided by 2. Our y position is going to be the screen dot height cast as a float. So screen dot height, and then we're going to subtract that from the foot position dot y. Alright, and then we're going to also subtract the height. Don't get the screen height confused with the player height, by the way. Alright, and then for the width, we're just going to do width, and for the height, we're just going to do height. And then for the color, I'm going to put in the color here. And then for the thickness, we'll do 2. Alright, so now we're going to do the snap line. So we're going to do snap line, and then render.drawLine, new, vector 2, float, screen dot width divided by 2. Alright, and now we're going to do float screen dot height divided by 2. And this is to put the line in the center. So the first point that the line's being drawn at is going to be at the center on the crosshair. You can do it on the bottom of the screen. All you'd have to do is do -1. Alright, next up is the other point. So we're going to do new vector 2, and this is going to be the point that connects to the feet. So new vector 2, foot position dot x, and then float screen dot height minus foot position dot y. And then we're going to put in our color and the thickness. There we go. And now we have everything here. So now that we have our function here complete, we actually need to call this. So we're going to do if world to screen foot position dot z is greater than 0. This is just to check that it's not behind us or anything. And then we can just call drawBox ESP, alright, and input our parameters. So foot position, head position, our color, I'm just going to do color.red. And there you go. Alright, so I actually made a mistake here, made a little typo. This here, player foot position, this should be player head position. Alright, and also remember I changed the player head position, so make sure that you change that too. Additionally to the world to screen head position, otherwise it will not work. Save that and build it. Simple mistakes like that. That's why you guys gotta watch the entire tutorial through. I know it's annoying. I know you'd rather just copy it, unless you want to actually learn something. But yeah, things can be annoying like this, but that's what coding's about, troubleshooting. Anyway, let's get into muck. So now that we're in muck, we're just gonna go refresh the process, find our assembly to inject it. You can see our ESP text here, and here we go. We have a working ESP for muck. So we have our snap line, snaps to the bottom of the box. There you go. It's an ESP. This works for any Unity game. You're gonna have to adjust certain things like the height and the width. That's how it is.